Hi, Math 92, homework number 8. Number 1, the number of students who are enrolled in math class at the local college can be represented by E equal minus 15W plus 580. What you have here in this problem is we give you already a formula, which is E equal minus 15W plus 500. And in this formula, E represent number of students and W is number of weeks, okay? So on the first part, they're saying when it's 0, when W is 0, what is the E value? So obviously when you put that 0 here and multiply by negative 15, that would eliminate the first term, so all is left is 580. Part B, they're telling you, what if we have number of students already? There are 430. In that case, they ask us to find the W. This is like an equation that your W, your variable, is on this side. So in that case, we just subtract 580 from both sides. And then we solve the problem for W. So these are the problems that in the beginning, again, we give you the equations. Then once we give you W and ask you to find the E, or vice versa, we give you E and ask you to find the W. And then in part C, they're saying, what if the W is 7? If the W is 7, then what's the value of E? Again, E in the equations, instead of W, you substitute 7. And then that gives you the value of E is 475. Problem number 2, gasoline prices in Southern California can increase very quickly during the summer months. In this one, they give you these equations. This is the equation that price is 3.899 plus 0.0 W. Again, W is number of weeks. Part A, what does gasoline cost after 5 weeks? After 5 weeks means we are giving you the W and we want you to find the price. And then part B, again, is vice versa. We give you the price of the gasoline, what you have on this side, and we ask you to find a W. So for that, this is part A, which W is given. W is 5 weeks. And we ask you to find the price, gasoline prices. So you simply take that 5 and substitute here, multiply by 0.038 plus that. That gives you this number, the dollars. Part B, it's we give you the price, 4.259, and we ask you to find the W. In that case, first I have to remove 3.89. I have to move it from the right to the left side by subtracting. That gives you 0.36 on this side and 0.03 W, divide both sides. That gives you the W is 12 weeks. So it's very similar to the first problem. It's just One time you find what you have on this side, then we give you what you have on the left side and ask you to find that one. Problem 3. Problem 3, again, the price is 5.5 B minus 460.5. P is the profit in dollars, and B is number of books. Again, first they ask you to find the profit if you sell 55 books. The second part, they give you a profit. Second part, they also ask you to find the profit when it's 230 books. And then the third part, again, is when we have the profit and we ask you to find the number of books. See, part A and B, we give you the number of books, which is B. In part A, B is 55, you put it in these equations. And on part B, B is 230. See, one thing you notice that when you with 55, you end up having negative 158. When you have it, see, P is the profit. If the profit is negative, means there is a loss. This is sales minus the purchase price or the cost. The difference is the profit. So if this value is less than, if the sales is less than the cost, obviously you end up having a loss, a negative. On part C, profit is given is $4,000. They ask you to find how many books do we need to sell in order to have $4,000 here. So what you do is you take this 460.05 to the other side first, add, and then to find the B, the difference should be divided by 5.5 to get the B value. So that would be that one. Number 4, the formula is given. Number 4, the formula is pay is 0.05 in the parentheses S, which is amount of the sale minus 520. So this formula is given. Part A, how much total pay will you earn from 1,500? If you sell 1,500, how much do you pay? Simply, you take the 1,500 and you put that here, and then you do distributions. You end up having $49. Part B, how much total pay will you earn if you sell 5,500 in sales? First it was $1,500, now it's 5,500. Here it would be 5,500, okay? So that's what you have now. If you sell 5,500, then you have 249 for your price. or pay. So you subtract these two and then multiply by 0.05. Now, part C, if you need at least 350 per week, what is your sales? See here? If your pay is $350, how much S? S is unknown. How much is your pay? How much do you need to sell to make at least $350? Now, when you do the distribution of 0.05, you end up having that. They add 26 to both sides. So divide, and S is that much, 7,520. I skipped number 5 because it's very similar. Now, number 6. A local cellular phone company has a pay-as-you-talk plan that costs $16 per month and 30 cents per minute. This is a formula. See, the cost is 0.3 times number of minutes plus 16. So part A is they just want you to write a formula. Part B, what if you speak for 180 minutes? So again, the cost is $16 per month is the flat fee. And they charge you 30 cents per minute, which is 0.30 per minute. If you speak for 180 minutes, what would be your monthly? 180 times 0.3 plus 16, which is 70. Part C, how many minutes did I talk when my cost is $59.50? Now, how do I solve this equation for M? First, I need to move 16 to the left side. And then divide the result by 0.3. So that would be, so M is 59.5 minus 16 divided by 0.3. That should give you 145 minutes. All right. Number 7, determine a scale that will allow the given data to fit the graph without breaking axis. Okay, so these numbers, it's 0.0005 and 0.001, 0.3. So if you have something like this, if you start with 0.0005 and multiply that by 2, if you use your calculator, take these numbers and multiply by 2, the calculator would give you that. Then if you multiply this by 2, you get this. Then you have this and you have that. So you see the scale? So when you start with 0.005 and every 2, it depends what you are using, 2 inch, 2 feet, whatever. Every 2, you have these numbers. That's why we start with that scale. See, that is scale of 0.0005 help you to find the other numbers. Because see, but the other numbers like 1, 10, 20, they're not here, they're just too large. These are all very similar. See here. If your scale is 500, then it would be what? 1,000, 2,000, 3,000. So that would be a good scale to use because the largest number here is almost 7,000. So why do we need these two? And we don't need one, it's too small, or 0.01. So we start with 500. So if it's 500, you could multiply by that by 3, just say multiply by 3, it said is 15, and 45 if you multiply by 3 again, and then when you multiply by 3, they give you large numbers. So I think that would do it if you start by 500. You could even start with 500 and multiply by 2 if you want. See, you could start with 500 and multiply by 2 and make it 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, and 7,000. See, these numbers, they all would take care of 2,000 to 6,700. If you use that as scale, then you could just say 2105, 21 is somewhere here, 3550 is somewhere here, 4,700 is here, 67 is here. See, you pick a scale that cover all the numbers that you have in the problem. Now, here, they want you to find coordinates of this point. What is x and y of this point? You understand that horizontal axis is x, and this is y, x and y. Okay? Like, what is coordinates of this point? Let's just as an example. This point, x is what? X is from here to here is 3, right? 1, 2, 3, which is 15, right? X of this point is 15. When you want to write a pair, you always write the x first and then y. Y is from here to here. This is the y of this point, and which is what? 20. So this coordinates of this point, x is 15 and y is 20. So what about this point? This point doesn't have any x, but y is 5. So we write it as 0 and 5. Again, the first number is always x and the second number is y. Second one is estimate the horizontal intercept. What is horizontal intercept? Where the line hit the x-axis. My line hit the x-axis at this point. What is coordinates of this point? From here to here is 5, this is 5 and this is 10. So roughly this is 8. This point doesn't have any y value. So what is coordinates of that point is 8 for x and 0 for y. We call this red one x-intercept. X-intercept is the place that my x or horizontal axis hit the graph or intersect the graph. Now they're talking about input and output. You know, when you have an equation like this, let's look at this one here. This is another example. When I have the equation like y equal x plus 1, for me to graph, I need some points. Let's say x equals 0. In x equals 0, how do you find a y? Don't you take these numbers and substitute here to find a y? So this number is all the x's is on the input, y is the output. Like here, you give 1 to x, you input x with 1, what is the output? 1 plus 1 is 2. X is input, y is output. You have to assign a value to x first in order to find a y value. So in that case, estimate the input value that make the output 20. Means what x would make the y 20? What is y 20? You cross the line. This is y 20, right? What x does that have? When x is 20, when y is 20, from here to here is y, right? When y is 20, you draw the line to hit the graph, and then you draw a perpendicular line to find your x. X is right here, minus 22. Minus 22 for x. D, estimate the input. Find the x if output is -5. What is the x value when y is -5? What is y equal -5 is right here. So you draw the line to hit the graph at this point. Hit the graph at this point, okay? So what is the x value for this? 15, from to here is 15. The last one, estimate the output, means find the y when input is 20. When x is 20, what is the y value? x20, where is x20? Right here. This is x equal 20, okay? Draw the line to hit the graph. This point, the x is 20. What is the y value? What is the y value from here to here? -8. So this point, x is 20, y is -8. Same thing. Find the x-intercept. X-intercept is the place that my line hit the x-axis. Right here. It's almost 13. So the first one is 13 and 0. See, this point doesn't have any y value, right? That's why y is 0. First number again is always x. The second number is y. This point doesn't have any y value, but it does have an x, which is almost 10, 13. B, estimate the y-intercept. Y-intercept is the place that my line intersect the y-axis. You could read that point is -10. So the second one is x is 0, y is -10, because all the y-intercept all the y-intercept. They don't have any x. This is a place that my line hit the y-axis. This point doesn't have any y value. Okay. C, estimate the value of x that result in y equal 8. Means when y is 8, what is the x value? Okay, let's find the y equal 8. Y equal 8 is right here somewhere, all right? So if you go straight here to hit the graph, x value that y is 8. Okay, y is 8, it hit the graph here. So you just come down. It's almost 25. So 25. Estimate the value of x that result in y equal minus 17. Means if y is minus 17, what is the x? What is y equal minus 17? Somewhere here, right? So if this is the minus 17, let's just draw the line that hit the graph at this point, and then let's read this one. Is almost minus 9. The last one, find the value of y when x is 20. X is 20 is here, right? When you rise it to hit the graph, what is, when you do this, what is the y value? 5. So basically, if you have an x and y axis, okay? And you have a line like this. If I give you a point, which is here, x equal 7, and say, what's the y value? From 7, which is x, you go up to see where that hit the line, and then you go this way to read the y value. Let's say here y is like 15, okay? Or if I give you the y value, I say if y is 3, what is the x value? Okay, just on the y, you say 1, 2, 3. This is y3, right? What is the x? You draw the line to hit the graph. This point, x is 3, y is 3, x is like minus 1. Very similar. These are all very similar. Now here, determine whether the following represent a function or not. What is functions? If you have equations like, let's say like y equal x plus 3, right? This equation, for every x that you pick, you always have a y value. X is 1, there is a y 4. X is 0, y is 3. X is negative 1, y is 2. This graph is a function. One of the definition of function is for every x, you have the y. X1, y1. X2, y2. See? X1 give you a y1. X2 give you a y. For every x, you have the y value. Well, let's look at this equation. So here, let's pick some numbers. X equal 1, y is 1 to power of 2 is 1 plus 6. How about x equal -1? What happened when x equal -1? Let's try. You substitute -1 for x. -1 to power of 2 or -1 times -1 is 1. 1 plus 5 is again 6. So this should be 6, I'm sorry. So you notice for two different x, you come up with the same value of y. Let's try another one. Let's say x equal to 2. We put it here. 2 to power of 2, y is 2 to power of 2 plus 5 is 9. What if I put -2? Again, for -2, you have the whole thing to power of 2 plus 5. So is 4 plus 5 is 9 again. Look, for two different x, you come up with one value of y. This is also a function. Is okay. See? So whether for every x you have one value of y or for 2x you have the same value of y is a definition of functions. Now let's look at these equations. Y is the plus or minus x2 minus 1, for instance. Okay? Now here, when x is 2, then you have what? You have 2 to power of 2 minus 1 or plus or minus 3. You have positive 3 and positive radical 3 and minus radical 3. For one value of x, you have two value of y. For one value of x, you have two value of y. This is not a function. Not a function. So we don't have, it's not a function if for one x, you come up with two different value of y. It's completely opposite of these two. So these are for functions. Not a function is that for one x, you come up with two y. So you got to remember these definitions. All right, so let's look at here. It is a function. Look, for every number, you have different numbers. So for every input, you have a different output. Number 13. When x is 1, y is 30. When x is 1, y is 36. See, for one value of x, which is 1, you have two different value of y. See? Not a function. If you find a situation that for one x, you have two different y, then that is not a function, which is here. X equal 1, y is 30. X equal 1, y is also 36. How about this? It said this one is not a function either. Let's see. Look, 510 the output is for 5 feet and 10 inch, the output is 86.4, right here. Also for 510, the output is different, it's 91. So for 1x, you have two different y. That's why is not a function. Now this one, instead of giving you all the numbers, we give you the plot of the numbers. You know, let's look at these numbers here. Let's say x equal to 5, right? What is the y value to this? Let's say y equal to, I don't know, let's say 8. What about this point? This point has the same x. But y is different. Y is like 12, okay? See, these 2 points, they both have the same x, but different y. So it's not a functions. See, this point, x is 5, from here to 5, y is 8. This point, x is also 5, y is 12. See? So they have 5 is 8 and 5 is 12. I mean, for 1x, they have two different y. There is another test, they call it vertical and horizontal test. And that's if we give you a picture of the function and ask you to tell, or I'm sorry, if I give you a picture of the graph, because we don't know if it's a function or not, and we ask you to tell whether it's a function or not, there are two tests to do. One, they call it vertical test, and the other one is horizontal test, okay? So let's look at this equation first. I have this graph. First, I do the vertical test. Vertical test is you take the straight edge and you move from left to the right. This vertical line hit the graph at just one point. You see that? This vertical line, when it's moved, it hit the graph at only one point. We also have the horizontal test, which if you go this way, it hit the graph at 2 points. But right now we care about vertical test, okay? So let's look at this equation here. This graph, oh, sorry. Does this graph pass the vertical test? You bring a straight edge, you move from left to right. No, because it hit the graph at 2 points when you move it. See, if it hit the graph or intersect the graph at more than 1 point, it is not a functions. This one is a function, yes. It does. This one failed the vertical test. This one passed the vertical test. Okay, what about this one? Does it pass the vertical test or fail the vertical test? Oh, I think it passed the vertical test. See, because it just hit the graph at 1 point. Let me show you. See that? It just hit the graph at 1 point. But look at this one. This one we talk about it. It doesn't, right? It's just like this. Okay. So this one doesn't. This one does. Now here, what is g of something means? Let's say there is a function of f of x equal x plus 2. You know, f of x and y are the same things, okay? When we say find f of 2 means what? Means take 2 and substitute for the x. So f of 2 is 4. What is f of 3? Means take 3 and substitute for the x here. It's very similar to draw the table, have x and y, and then say, okay, if x is 2, what is the value of y? 2. When x is 3, what is the value of y? 5. It's very similar. So f of something or g of something means take that number and substitute, okay? So let's say you have a g of x functions. We don't have the equation here. We have the graph instead of equations, okay? G of -1. What does g of -1 means? G of -1 means when x is -1, what is the value of y? That means on the x-axis, find -1, okay, and draw the line to hit the graph at the point. Read the coordinates of this point. What is the y value of this point? When you go this way, what is the y value when you go this way? It's -2. So you just say -2. G of -3 means when x is -3, what is the y value? When g of -3 means, what is g of -3 means? When x is -3, this is a different problems, okay? But here, in this one, when x is -3, how do you find the y? You just put it here, you say -1, okay? In this one, g of -3 means when x is -3, what's the value of y? Okay, where is x equal -3? It's right here. This is x equal -3, right? Draw the line, vertical line, to hit the graph at the point. Then go to the right to read the points, which is 4. That's how you find it. Estimate such that g of x is 1. What if x is 1? What is the value of y? X equal 1 is here, right? Oh, this one, I'm sorry. This one is said g of x is not very clear. Part C. It said g of x is 1. G of x equal 1 means y is 1. Now, find the x. Because g of x, f of x, they all means y value. See? Y equal f of x, y equal g of x. So when it said g of x equal to 1 means y is 1. If y is 1, what is the value of x? So here, on the y-axis, you find the y equal 1, and then you draw the line and find the x value. Okay, so it's like, let me have a better picture here. That is too crowded here. When y is 1, this is y equal 1, right? You just go this way and then go up that way. This is your x, which happened to be -2. What is domain and range? Domain is all x's, and range is always y value. This graph can take any value for x. Like if I give you these equations and ask you to say domain and range, means can I substitute any number for x? Say yes. Domain is x. So it said domain is yes, all real number. Can I put any number for y? Yes. Range is y value. For this one, domain and range is all the numbers. Estimate g of 3. Estimate g of 3 means when x is 3, what is the y value? X equal 3 is right here, look. This is x equal 3. You draw the vertical line. To hit the graph, then you draw the line. You want to read the y value of that point, right? So you just go this way to see what is the y value of that point. 8. So you say y is 8. X equal 3. Draw the vertical line, hit the graph, go to the left, that gives you the y value. Find g of -1. G of -1 means when x equal to -1, what is the y value? Where is x equal -1 is right here. This is x equal -1. Draw the vertical line here. Go up. You hit the graph. Go to the right. Same thing. Is 8 also. So whether you have x equal 3 or y equal -1, both have the same y value. Part C, g of x is 8. What does g of x? Means y is 8, find x value. Now y is 8. Okay, where is y equal 8? Is right here, right? What is the x value? You go to the right, to the left, go down. These two, 3 and -1. -1 and 3. Because both of these x's have the same y. What is domain and range? You know, these functions, it goes all the way to positive infinity and negative infinity. But the function does not, on the y-axis, this is a y-axis, okay? On the y-axis, function does not go below 4. See, look. It doesn't go below 4. So on the y-axis or the vertical, it doesn't go. There is no function below this. So then you just say range is always y, is 4 to infinity. But domain, I'm sorry, domain is minus infinity and infinity. Why? Because domain, this goes all the way to infinity and negative infinity. It's like, if I want to exaggerate this, it would be something like this. The function goes all the way to negative infinity and to positive infinity. It goes all the way. See, these are all, see all these x's? The function goes all the way to the, but as far as the y, it doesn't go below 4. Stop right there. You don't have anything below 4 for the y. So range is 4 to infinity. All right, so that would be end of chapter 8.